Okay, so I'm back. This will be our last sample problem. That this will be very comprehensive in terms of the basics of this type of sample problem. Okay, so let's read together. In the position shown, color B moves to the left with a constant velocity of 300 millimeter per second. Excuse me. Oops. Sorry about that. The question is, what is the velocity of color A? The velocity of portion C of the table, and for the first time, the relative velocity of portion C of the table with respect to the color B. Okay. So first things first, datum line. I'm gonna put datum line here because it is appropriate. Second, absolute positions. Absolute positions for B should be SB. For A, I'm going to use here at the center of that pulley SA. There are only two objects, so you only need two absolute positions. Next is the equation. So for the equation, you only need one equation. Length is equals to, that would be SB, correct? SB. First line is SB. The second is SB minus SA. So for the sake of simplicity, we're gonna add something like C here. Okay. For us to easily see that the next distance here is equals to SB minus C minus SA. Okay. And the other distance, tapos na tayo sa gini. Next is this, that would be SA. And the other one, this is 2SA. Okay. Okay. So for the equation, velocity equation, that would be 2VB 0 plus VA. Wala sa acceleration. Okay, so question A is the velocity of color A. VA is negative 2VB, and the beam is moving 300 to the left. To the left means positive. So VA is equals to negative 2 times VB, which is positive 300 mm per second. That would mean negative 600 mm per second. Or VA is equals to 600 meter per second, negative to the right. Okay. VA. Next, velocity of portion C. How are we going to solve for portion C? Just like what we did to the previous example, no? We remove the other side of the rope, but this time, which part of the rope we're going to remove? Let's try both. In this case, I'm going to treat the rope as this one. Okay, sorry, so low. Okay, that's this one. So for letter B, we have to make a position for point C. We have to add this is SC. Okay. To BS. Again, let's check if SC is absolute position. Is it absolute position? Maybe. We can check later. Okay, let's continue. That would mean the new equation, length equation. Length is equals to SC plus 2SA. Yeah, that's right. VC plus 2VA. So VC is equals to negative 2VA, which is the same with VA initially at question A. But VA is 600, which is negative. Negative 2. VA is negative 600. Hey. Which means VC is 1, 2, positive 1, 2. Or VC is equals to 1, 2. Positive means leftward. We can verify this one using another part of the row, which is this one. Can we do that? Because the two endpoints of this row are moving, unlike the other one which has an endpoint here which is fixed and an endpoint here which is moving. This time I think the answer would not be the same because the 2 points are moving. But let's try it anyway. For case 2, still letter B. That would mean SB, length is SB minus SC, and the other one is SB minus SA. SB minus C or minus SA, just like this. Minus C minus SA. So length is equals to velocity 2VB minus VC minus VA. So to solve for VC, 2VB minus VA. 2VB is this one, 300 to the left, that would be positive, minus VA, which is negative 600. Ooh. Are you seeing what I'm saying? VC is 1200 nm per second, which is okay. So the question here is, yes, we solved for VC using 2 cases. The other one is using 2 parts of the row. But the question is this answer just luck, or is this absolute? That's the question. This 1200 mn per second, is this absolute velocity of point C? Since if we are going to analyze it, the 2 points here and here, the length they are relative, they are moving. But does anything say about the exact and general procedures? No, because if you're going to compare it with here, ang lengta from point A all the way to here, this one is fixed, this one is moving, so that's valid. Is that a hard rule? Is that a no, because diri gani okay man siya, wala man problema. From point B to point T, okay, point D is moving, point B is moving, so they're still valid. So it doesn't matter if the endpoints of your law are both relative, or one is absolute and the other is relative. So that's why pareho na ito ng answer. I just suspected nga naman. So it applies only to positions but not to row length. Okay? It applies only to positions, not to the length of the row. As we shall see later, may question din what is the relative velocity of portion C. Ma-distinguish din ang difference nila. Alright. Now, let's go to question C. Let's go to question C. I'm gonna write it here, maybe here. The question C is the relative velocity of portion C. Ang D yan is velocity of portion C, which is absolute. The follow-up question is still on C, but this time the relative portion of C with respect to B. Okay, with respect to B. So actually, the positions that we're going to use is relating B and C. This, as you notice here, this position is not absolute because the two endpoints are moving. Therefore, SB, okay, or you can say SC or SB, doesn't matter. Just that this is relative. This is relative, even though this notation is not strictly relative, but this should mean relative because the two endpoints are relative. So we're going to analyze zero C or B or whatever. C/C. Okay. So okay. How are we going to do that? The relative velocity of portion C of the cable with respect to the color B. With respect to the color B. Do we have color B? Yes. Actually, we can do both solutions. The question really is CB. So CB is just BC minus BB. Ano naman na sa iba? We have BC, we have BB, so plug in. BC is absolute is 1, 2. Do not use this one, use this one. And minus, that's the operator. BB is 300 leftward, that would be positive. You're both leftward. VC. Point C is moving and B is also moving. But BB is 300, BC is 12, so the relative velocity is of course subtracted. That would mean BC slash B is 900 na lang. So 900. This is positive. So positive means leftward. But why leftward? Because they are both moving leftward. Okay, can we solve this? Can we arrive at the same answer using different solution aside from this equation? Using length equation. Can we? There's no other way. There's no other way. Because we have already tried this one. And my first assumption is that this would result to absolute relative velocity of C with respect to A, or VA with respect to C. But that's not the case because it equals with VC. And we also compared it at the top now. That the solutions for this and this are valid. Okay, so this is the only solution for the last question. Okay, so my suggestion for you now is to try to solve this same problem, but this time try to have a datum line on the left side, this one. If you could generate the same answers A, B, and C, that would mean you really understood the key principles or key concepts of this type of problem. Okay, so that's all for today. I hope you learned something new and got excited by this topic. So there are a lot of sample problems, interesting sample problems on mechanics books. No? Just try to practice them on really interesting sample problems, no? Especially this one. Okay. So that would be all. Thank you for your attention. Okay. Correction galit lagi na. Very sala ni siya. It should be to the right because kita tama sa babaw. Position of SC is that, and position of SB is that. So if you isolate them, this should be SC, this should be SB, and question is SC slash B, meaning the arrow should come from the head of the B. So that should be to the right. Now, to see it in terms of polygon, if this is indeed correct, let's try. This would be SP, SC slash B, and then SC. And as you can see, the vector sum of these two is equals to SC, which is SC is equals to SB plus SC slash B. Polygon method. Head to tail, head to tail, head to tail to head, tail to head, tail to head. And if you transpose, means SC minus SB, which is correct. Okay? So to the right to siya kagina, sa lahat kagina. Okay?